So in order for us to start making a little sense of what we say, and I would say this is the bad thing with academicians. We don't take anything for given. We go back and we start from the very beginning. And if you're going to communicate something, you've got to communicate it accurately. And semantics matter a lot. So what is blockchain? Define it, right? And I go back and I say, what is blockchain? Well, the blockchain is the technology behind cryptocurrencies. I mean, that's where things started. Suddenly in 2008, what was happening in 2008? We had all this financial crisis and the banks were a mess, right? And all of us started feeling very uncomfortable about all those people sitting in the middle and what were they doing with our money, right? And then someone comes and says, look, I have a very nice solution that is going to allow us, right, to do all those financial transactions and exchanges without having anybody sitting in the middle through a very innovative solution. And that's where the blockchain comes, right? So I gave you two definitions. I'll just pick one. And what was the solution that came at that point in time that we called it a blockchain? The solution was the following. It is a distributed ledger. It is a distributed database, right? That actually anybody that has interest can access it and have a copy of it. It's permissionless. Anybody that participates in it, right? We can impose the right cryptography that is going to make sure that we're pseudonymous, right? People don't know about us if we don't. And the cryptography technology is already there and has the two keys, the private and the public keys, right? As we said, it's replicated across all nodes that participate, and anyone that has a computer and would like to participate in it will come in, right? And of course, everybody reads. The important thing is data gets stored, and data over time is going to be verified. The way the data gets stored is one block at a time, and then the next data is the next block, and it's going to be appended to that block, and those blocks will be connected, right? But the most important question is, who verifies the new block of data? And the substantial innovation there was, there's nobody really. All of these independent agents that have all the objectives to cheat, like all of us. They compete, all of them trying to verify the next block of data. They have to solve a very difficult combinatorial problem. Which one of them finally is going to solve it and get some rewards, but all of them are going to verify and accept it, and that is the consensus. And that is how the way it is guaranteed that that data is verified and it is accurate and is fully connected to everything else. And because of this protocol of how those things are happening, it is impossible to mess around with any piece of data. Because if you try to mess around with any piece of data, you have to go all the way to the beginning. And you have to verify the next piece of data and go back and verify everything else and do all of that within 8 minutes, which is impossible. Therefore, all of us, with all the bad intentions to cheat for our advantage, we end up to accurately verifying everything that is happening without any one of us being able to cheat. Someone came and said, nobody needs to sit in the middle in an environment with all those independent agents that non-cooperatively are going to compete, right? Solving this very difficult combinatorial problem over a very short period of time. Basically, a non-cooperative game and an algorithmic protocol is good enough to make sure that all data is accurately verified with nobody occupying the middle, right? So this is the so-called software-driven consensus algorithm, which is the heart of the innovation. So that's what got people excited, right? That's blockchain.